Hey guys, math teachers love this equation. And more importantly, they love to say this about this equation. But when a teacher writes this on a board, this is not correct. We can disprove it with a counterexample. Let's let a equal 0 and b equal 4. We'll plug in 0 for this a, 4 for this b, copy down the does not equal, plug in 0 for this a, and 4 for the b. This left-hand side is just going to be 4 squared, so the right-hand side is just 4 squared. This leads us to the conclusion that 16 does not equal 16. That is not correct, so this statement up here is not correct. So you have to be careful with does not equal symbols. Here's an example that's used correctly. X cannot equal x plus 1. There is no counterexample to this. There are an infinite number of examples that do work. For example, x equals 15. On this left-hand side, we plug in 15 for x. On the right-hand side, we plug in 15 for x, which gives us 16. Since 15 does not equal 16, this is still true. This is a true statement. There is no counterexample for it, so we can put a box around it. But how can we fix this? But what are teachers trying to say with this? This is what they should be saying. They can say a plus b squared does not equal a squared plus b squared, but they need to say if ab does not equal 0. Now there are no counterexamples. Now we can put a box around this because this is a true statement. Even though this is universally true, doesn't mean that if it changes at all, you put an inequality because it might be true sometimes. How exciting.